In this video, we're going to prove that there's an infinite number of primes of the form 4n plus 3. And just for the record, every number can be written in the form of 4n, 4n plus 1, 4n plus 2, or 4n plus 3. And I don't care how many prime numbers are of this form, say 0, of this form, let's say 23, of this form, say 11, and of this form, we're going to prove that it's infinitely many. Well, that would mean that there's an infinite number of primes. So if you just notice an infinite number of primes of one form, then there's an infinite number of primes altogether. Because all you're going to do is possibly add in more primes of other forms. Okay. Before we get into the proof, I want to ask you folks to please subscribe to my YouTube channel. All I do here is show proofs of various theorems. If that's what you are into, then in my opinion it's a no-brainer. Subscribe to my channel, like my videos, and leave comments. Now, before we get into the proof, there's a couple of lemmas that I need to get out of the way. So first, every integer, let's just talk about positive integers. Every integer is of this form, of these four forms. If you're of the form 4n, then you're 4, 8, 12, 16, 20. You're even. You surely aren't going to be prime. These numbers are 2 more than these numbers. 6, 10, 14, 18, 22. These numbers are not prime. So 4n plus 2 is not going to be prime. You can also argue that it's 2 times an integer. Okay, and if n starts at 1, that integer is at least 3. 2 times 3, it's an odd integer, 2n plus 1. 2 times 3, 2 times 5, 2 times 7. Well, that makes no sense because I'm getting even numbers. It's 2 times 2n. Yes, yes. This is 2 times 3. This is 2 times 5. It's 2 times an odd number. The odd numbers. 2 times 9, 2 times 11, it's always prime. It's on the 2 times table. So these numbers, no prime number can be of the form 4n or 4n plus 2. Now we want to look at 4n and 4n plus 3. Do they have any primes? Well, let's see. 4 times 1 plus 1, that's 5. That's enough to convince me that 4n plus 1 has some primes. If you look at 4 times 3, that's 12. Plus 1 is 13. Has a second prime. 4 times 1 plus 3 is 7. That's prime. 4 times 2 plus 3, that's 11. That's prime. Both 4n and 4n plus 3 definitely have prime numbers. So every prime number is of one of those 2 forms. Of course, every number is in the form of 4n, 4n plus 1, or 4n plus 2. And these numbers are never prime. So the only possible forms of prime numbers, especially when we showed that each of those 2 remaining lists have a prime number, are 4n plus 1 in 4n plus 2. Now, let us look at what happens when you multiply a number of the form 4n plus 1 by another number of the same form. You're going to get 16nm plus 4n plus 4m plus 1. I hope it's clear that what I just bracketed off, you can pull a 4 out of it. So it's a 4q plus 1. So on the side here, let's record that. If you multiply a number of the form 4n plus 1 by another number of that form, you get back a number of the same form. Okay, what happens if you multiply a number of the form 4n plus 3 by another number of that form? Well, you're going to get 16nm plus 12n plus 3 plus 12n, or m, plus 12n plus 9. But think of the 9 as 8 plus 1. Now, if you bracket up what's in there, all of these are multiples of 4. So it's 4q plus 1. Okay, so if you multiply a number of the form 4n plus 3 by another number of that form, you get back a number of the form 4r plus 1. 4r plus 1. Alright. 4 times an integer plus 1. What if you multiply one of each? If you have 4n plus 1 and you multiply by 4n plus 3, 4m plus 3, you'll get 16nm plus 12n plus 4m plus 3. What I bracketed up is a multiple of 4. So it says, we'll say it's 4s plus 3. So if you multiply a number of the form 4n plus 1 by 4m plus 3, you get back a number of this type, 4s plus 3. Okay, so let's just keep that on the side. Okay, now that I got a few lemmas out of the way, let us get right into the proof. Okay, so it's standard. If they say, if we want to prove that there's an infinite number of primes of that form, assume otherwise. Suppose there exist only finitely many primes of the form 4n plus 3. Let them be Q1, Q2, say up to Q sub s. So now, like always, we want to kind of say for the product of the primes minus 1, give us the type we want. But we keep having this 4 involved. Okay, we have this 4 involved. Just for the record, if you're of the form of 4n plus 3, I can add 1 and take away 1. Now, this is just 4 times the number minus 1. Well, that's still not. Okay. We'll use that in a moment. So now, what happens is, we consider this number. So consider the positive number n. And n is 4 times the product of all the numbers. There should be an s at the end. I'm positive that I said s, I just didn't write it. Minus 1. Okay? But now, this is the same as 4q1 up to qs. Now, I'm going to take away 3, and then I'm going to add the 3 back. And I can bracket it like that if I like. And then what I get is that n is equal to, between here and here, I can pull out a 4. It's 4 times the number q1 through qs minus 1 plus the 3, and that's in q sub s. Okay, so n is of this form. Now let's talk about the prime factorization of n. Suppose the prime factorization of n is r1 times r2 up to r sub t. Okay? Which makes sense. It's a product of prime numbers. Of course, all those numbers are prime. Okay. Note that n being in the form 4 times a number plus 3, let's say 4q plus 3, that implies that n is odd. Because this is even, and if you add an odd number, you get an odd. Okay. That means that no prime factor, none of these r's could be 2. That implies r sub I is not 2 for all r's between 1 and t. For all I between 1 and t. The subscripts are between 1 and t. Okay, so none of them are 2. Okay, so let me think what we want to say here. Well, that implies that r sub I are the r sub i's, all r i's are of the form 4n plus 1 or 4n plus 3. Okay. Now, remember, the only way to get 4 times the number plus 3 is if one of the factors are of the form 4n plus 3. Okay. Since n is of the form 4n plus 3, that implies some Ri is of the form 4 something plus 3. I'm just looking for a letter. Say 4t plus 3. So some R sub I is of this form, which makes sense because if none of the R sub i's were of the form 4n plus 3, then n would be of this form. But n is of this form. It must have at least one factor of 4n plus 3. In fact, it can only have an odd number of them. Okay. Okay, now, suppose R sub I is in this set, Q1, Q2, up to QS. R is one of these. R is one of these. That is, R sub I equals Q sub J for some J. For some J between 1 and S. That is, Ri is one of them. Okay, now Ri being a prime factor of our n, Ri must be a factor of n. But we're going to look at n as, say, this one. We're going to look at n as that one. Must be a factor of 4 times Q1, Q2, up to QS minus 1. Okay, so let us just be a little bit clearer. It goes up to QJ, up to QS minus 1. Well, Ri being QJ definitely divides this. But the only way it's going to divide the whole thing is if Ri divides 1. But that implies that R sub I divides 1. And that's a contradiction, because the only number that divides 1, the only positive number that divides 1 is 1. And R sub I cannot be 1, because R sub I is a prime number. It's a prime factor of n, it's a prime number, and all prime numbers are bigger than 1. What are we contradicting? What are we contradicting? We're contradicting this. We're contradicting that there exists only a finite number of primes of this form. Hence, there must be an infinite number of primes of the form 4n plus 3. Let me just confirm that was what it was. 4n plus 3. And for the record, this implies there exist infinitely many primes. I don't care if there's an infinite number of primes of this form. We now know there's infinitely many primes. Okay, so the proof ends right there. You could end it here and say, hey, I showed something even more. that there's infinitely many primes. But this is another proof. It's long and it's somewhat complicated. But hey, you had to prove that there's infinitely many primes of this form. That's something you learn in number theory. So why not just use this proof to show that there's an infinite number of primes? You only learn one proof and it covers two theorems. If you like videos like this, please subscribe to my channel. See you guys in the next video. Please watch and learn.